Today, based on peer-reviewed vibes, we'll be looking at internal coatings, foam fillings, doing nothing and hoping for the best, doing a little bit of something and hoping for the best, TPU, and maybe casting. So a good way to test these might just be to dunk a bunch of samples in different depths of water. We can measure how much water is getting in by weighing the samples before and after. Think of yourself as a little cube of water containing one of our printed test samples. Now, we could add 10 meters of water above you, but more practically, we could just add compressed air. Prepare a bunch of sample cubes using our different methods. Build a vessel that can hold our cubes and handle up to 15 psi of pressure. Then we're going to submerge all these cubes and test at different pressures over different periods of time, weighing periodically to measure how much water is getting in. So I picked up this vacuum chamber. It's meant to handle 15 psi on the outside, so it should probably be strong enough to handle the same on the inside. The one caveat is the lid. So this is what I came up with. Here's the vacuum chamber as purchased. And we're going to add a bottom plate, some top plates, and some 6mm tie rods to clamp the lid shut. Here I've made a bottom plate with one chunky 3D print. The 6mm tie rods will thread into a nut in these little orange pieces. To remove the lid, we only need to loosen the top nuts and rotate the tie rods out of the way. The top nuts themselves will be captured in these little printed knobs.
Nope. No.
Now I'm in Canada. In theory, we're a metric country, but in practice, it's kind of a mixed bag. And much of that can be attributed to how our big southern brother loves them freedom units. Canada is pretty teeny in comparison, so much of the tools, trucks, ovens, and general stuff we buy is coming from them, and much of it brings along its imperial baggage. This means that despite being all aboard the metric train, your regular Joe Schmo Canuck won't be finding much metric selection at the hardware store. And it'll probably stay this way until the US decides to join the metric club. So, my American friends, you should come aboard the metric train. Join the global community. I know, the metric system was invented by those French commies. But are they really so bad? They did give you the Statue of Liberty. A single measurement system means half the sockets, half the wrenches, half the Allen keys. It means half the time searching for the right size. It means half as many trips to the toolbox and trying to fix that ancient lawnmower. Don't do it for me. Don't do it for the global community. Do it for yourself. Do it for the time you'll save. Do it for the bolts that'll remain unrounded because you didn't have to resort to the adjustable wrench. Do it for the extra cash in your pocket, and use that cash to buy more tools that expand your capabilities, because nothing says freedom like having the tools to do the job yourself. So anyway, I bought some 1/4-inch rod. I never planned on using metric rod. My whole life I've been dealing with this Canadian reality, and I accept my oscillating multi-tool, carbide blade. Now we have the rods, nuts, and the printed parts. All that's left is the top plate. Laser cut by this video's sponsor, PCBWay. They offer a bunch of services, including laser cutting, CNC machining, 3D printing, and of course, PCB manufacturing and assembly. They are also ISO 9001 certified. If you're not a huge nerd, this pretty much just means they follow industry best practices for quality and consistency. For this top plate, I simply uploaded my step file, selected my material, and got a very reasonable quote. This top plate turned out great. Check out my link in the description if you want to try them out yourself. Okay, so a couple changes. We added those extra rods. On the lid we added these little corner brackets just to help locate the top plate to the lid. Little corner pieces. And we also applied some silicone to the big gasket as well as these little seals in the middle here, which will hopefully let it seal properly. You have to make this one extra tall to clear this gauge here. So we'll pressurize that and hopefully we don't get any leakage. About 9 psi. We'll leave that for a bit, see if it drops at all. Still at 9 psi. Nice. So now all we gotta do is prepare samples. We're gonna revisit this stuff from our previous video. Apparently it's liable to become waterlogged. So we'll see how well it holds up. A lot of you also recommended this stuff. And finally we have a two-part foam, the kind of stuff you would fill your boat with. For best results with this single-part foam, you really need to fill and drain the part with water first. Otherwise the inside of your part might look like this, instead of this. For internal coatings, we're going to look at 5 different options. A few 2-part polyurethanes, a single-part polyurethane, and a 2-part epoxy.
Hello there.
Hey, buddy. Finally, we have 3, let's say, wildcards. We have our little TPU experiment where we encase a PETG cube in a layer of TPU printed on our tool changer. We have a cast polyurethane experiment, essentially making a mold with a thin layer of single part polyurethane. And finally, we have just printing thicker. Of course, we're also going to be testing a normal ass cube printed with default settings. Here's our semi-rigid sample. Clearly, we're going to need to do something about that. So I printed this little cap. We're going to use this and a little dab of silicone to seal all our samples. Look at all our samples ready for testing. We got our internal coatings here. We got all our foam samples. We got our TPU, our thicker print, our PU, casting, and our control. So we'll weigh these guys and then they'll be ready to throw in the pressure chamber and start testing. So one thing I didn't think of, after filling our vessel, if no air is leaking out, then the internal pressure should stay the same. But this is only true if our samples are perfectly sealed. If any of our samples spring a leak, that ambient air is going to want to equalize. It'll let water in. Pressure of the air in the sample will go up, and the pressure of the air in the vessel will go down until they're the same. Now, if our pressure is fluctuating all over the place, you might think this could present a problem for our testing, but I'm not worried about it, as we're going to use a secret technique that science hippies don't want you to know about. Sounds fancy, but really all we're saying is that we don't care about the results for this one cube in isolation. All we care about is, how much better is this cube than this one? We don't really care if the pressure swings all over the place. So now we can carry on, pop these guys back in the pressure chamber, and keep on going. See how much water they take on. So here we can see some results. For the first 44 hours, we had the pressure set at around 10 psi. And then for the last 48, we bumped it up to 15. All our internal coating samples actually did quite well with pretty much no ingress, except for our polyurethane rubber, which was doing great for the 10 psi testing, but as soon as we bumped it up to 15, it sprung a leak. We also tested samples of just the foam by itself, all of which took on quite a bit of water. Now, testing under pressure is all well and good, but to be robust, one has to be able to endure a good smack. What we really want to know is not only how well our methods keep the water out, but if they can still keep the water out after a high-speed collision or a close encounter with aggressive fauna. So let me introduce you to Lil Smashy. Pull this pin and it'll provide a calibrated WAP. Let's see how our samples do after an encounter with the Swedish hammer of moderate dent forming. You want to do a smash? I think he wants to smash. For this last round of testing, we're looking at only our best internal coatings. We're also looking at 2 bonus PU310 samples, one with a double layer of coating on the inside, and one with a single layer but also filled with a 1-part foam. So some nice results here. Obviously our crack sample let in a lot of water, but the other ones fared really well. Alright, so we got our 3 champions. We have the epoxy internal coating. We got the 310 polyurethane double layer. And we got the 310 polyurethane single layer but with an additional 1-part foam filling. All these didn't leak at all and survived round 1 with Lil Smashy, but I think it's time for sudden death. Our foam-filled sample did survive, but there's a crack. Double layer sample did not survive. Our epoxy sample has also gone over to the other side with a pretty big crack. Finally, we brought back our PU rubber sample, which is the only one without visible damage. So my personal recommendation for general use, the 310 PU. It's super thin and easy to work with. It's really easy to get a nice internal coating on your part, but it is not as impact resistant as some of the other ones. So if you want something a bit more impact resistant but still holds up really well under pressure, I would go the epoxy, though it is a lot thicker, so you have to have a lot more patience when you're filling. But if you don't care as much about high pressures, I would go with the PU rubber. It's survived the last round with Lil Smashy, and it did have no ingress at 10 psi during our testing. It's only at 15 that it started to fill with some water. We've also learned that all the foams, they all fill with water eventually. Congrats on making it to the end of the video. If you've had a good time or you've learned something, please feel free to comment, like, or subscribe, or just roast me in the chat again if you're feeling spicy.